Welcome to today's interview. We will focus on monitoring of protective systems for linear structures. We used an article in Sensors magazine by a team from the Technical University of Ostrava as our source.
Specifically, from the Faculty of Electrical Engineering and Computer Science, Department of Cybernetics and Biomedical Engineering.
Exactly. Specifically, it's about monitoring protective systems, such as fences and walls along roads and railways, and how to protect them from falling rocks or landslides using smart sensors. Let's take a look at how it works.
The article emphasizes that traditional visual inspections are simply expensive and slow, and more importantly, they often detect problems too late. A team from Ostrava has developed a unique wireless monitoring system. It's not just a few sensors, but a complete solution with remote access, data processing, and alarms, something that was missing on the market.
Standard solutions such as fences or gabion walls do exist, but their inspection is often only visual, which is expensive and slow.
So, a problem can arise before anyone notices it.
What technology did they use?
They have two main types of wireless sensors, or nodes, as they call them. The first one uses an accelerometer. It is used to monitor protective fences. The second type measures load using anchor force gauges. This is more suitable for retaining walls, such as gabions.
An accelerometer? How does it work?
It measures acceleration in 3 axes. It can distinguish between 2 things. First, a slow change, such as when a fence gradually tilts as debris accumulates behind it, which is the static component, and then a sudden shock when a stone hits the fence, which is the dynamic component. It is precisely this dynamic event that can immediately trigger an alarm, asynchronously and outside of regular automatic checks. In addition, the whole thing is designed for ultra-low power consumption.
And the second type?
That is a sensor for a strain gauge load. It is installed in anchors in slopes or gabion walls. It measures the tension in those anchors.
It measures the change in resistance of a special bridge, which indicates a change in tension, load. Any movement of the slope or greater load on the wall is thus reflected in a change in the measured resistance.
So one sensor listens for impacts and deformations of the fence, and the other monitors slow movements and changes in tension in the slope or wall. But how do they send that information out?
The key is Czech wireless IQRF technology. The main advantage is extremely low power consumption and the mesh network topology.
A big advantage is the resilience of the signal transmission. If one or even a few sensors fail, the data simply finds another route. In addition, it is very energy efficient, much more than other similar technologies.
I see. The technology sounds well thought out. Let's see how it performed in practice. The first case study is from Malkov. They had a test polygon there.
They built a test fence there. They mainly tested the accelerometer, manually simulating impacts and deforming the fence in various places. And the results? It turned out that the sensors reliably detect changes even far from the point of impact. What's more, from the data obtained, they were also able to approximately determine where the impact occurred. They also tested resistance in real weather conditions. Solar energy was used for power.
So it's useful to know immediately what happened and where. The article also mentions a live installation above the railway line near Zbraslav.
Protective fences above the railway line were monitored, where there is a very steep, rocky slope. They deployed the second, then the third generation of accelerometers there, and the function of asynchronous alarms was confirmed. The system immediately reported impacts, even those that occurred between regular measurements, such as in the middle of the night. This is essential for a quick response.
So immediate information must have been a big plus for operational safety.
Definitely. Knowing immediately that something is happening and not waiting hours or days for the next check is a huge difference.
In the latest study, Mokre-Lasche monitored the stability of the slope by the road. They used the second type strain gauge sensors and placed them in gabion walls. Previously, this had to be measured manually, but now they have continuous data on the load on the wall. The system thus allows immediate detection of any signs of slope movement.
This makes it possible to monitor long-term trends.
So it's not just about collecting data, but also about moving from reactive maintenance to predictive maintenance, not solving a problem when it arises, but preventing it. Thank you for your attention and tune in next time for another podcast.